whatever person you want to send that mail to, and at times you may write from your whatever. And inside is the actual email where you again write to or dear friend or whatever, which may not be the same as the actual sender name that you have specified in the envelope. So you can say dear friend instead of the actual name. So this is exactly how the email works. The top two commands, mail from and RCPG2, are the actual commands that constitute an envelope of the email. And then after that is the data command, where you actually push the email message onto the server, wherein you have all these headers called from, to, subject, or whatever. Non-standard headers start with X hyphen, whatever, and then you have the message. So the format is pretty simple, as in the HTTP protocol, where you have headers, header field colon, header value, separated by an empty line, and after the empty line, it means that the body of the message has started. So the body can actually in itself be a MIME body, which means that you can also have an attachment inside the email itself. Okay. So if you see, this from and to is whatever you want to specify. Okay. And this is the actual recipient of the email where you want to send the email. So inside you can write whatever you want, because this part is what is shown at the front end when you are using a client or webmail access. So we just try if it works with Gmail. It works at times with Gmail, not all the times. See the banner. Okay, so the first command is hello, where you specify your host name, and after that you say mail from with an empty. I'll talk about the empty mail from after some time. This is the actual email content with the headers of the body, which can be anything. So the single dot on the line means I'm finished, I'm done with my message. And if I get a reply back, this reply is a change of responsibility from my machine to the Gmail server, wherein Gmail takes the responsibility of either delivering this mail or sending a failure notice back to whoever is the sender. Now this empty is required to avoid loops inside the SMTP networks, wherein if you are sending a mail to, let's say, someone at yahoo.com is sending mail to gmail.com, and there's an error inside the server, and the server sends a failure notice back to Yahoo, and there's an error inside Yahoo server. what will happen is you will create a loop. So to avoid that, all the failure notices or whatever are with an empty mail from. So if there's an error, you don't send a failure notice back to anyone. Not sure if that message will come from. Got a very bad. So there are a lot of things that you can do at the server side. So some of the things are, there's a technique called gray listing, wherein what you do is you exploit the SMTP protocol itself. So what the server will do is, once it gets my IP address, it will obviously get my IP address when I try to connect to it. It gets my hostname, it gets a mail from, and it gets an RCPDB. Now what it will do is, it has a database of these 4 values. Okay, it will see if that entry is there. Not I think probably this and this are not mandatory. But it will see that if a client tried to connect to my server from this IP and this hostname. So if this is a new entry, what I'll do is I'll send a temporary error back to the client. So in effect, I'm exploiting the SMTP protocol, but what advantage I'm getting here is that there are rogue malware clients. What they do is, if you run them, they'll try to connect to the server, they'll try and send mail. If they fail, they won't retry. But any standard mail server like SendMail or Exchange server or any other, for that matter, like Postfix, if server rejects with a temporary error, what they'll do is they'll store it, they'll queue the message up for some time, they'll keep on retrying for a number of counts. So this is one way to protect against that. think it's not completed. It's my semantic that's getting problems. Okay. So as far as detection is concerned, there are other, not just, SMTP protocol is plain simple protocol on how to transfer email. There is no authentication, no thing. So anybody can connect and anybody can forge any email to this as easy as that.
Have access of your password. So that's all basically the basics of HTTPS protocol. Is it clear? Now you understand what is the use of VeriSign, why they have these techniques. So you should take care. Other thing is, while you are doing all these things, you should also take care while you are accessing a banking site or some login credential site like Gmail, Google or whether it's HTTPS URL or not. This is your Gmail page. It is saying HTTPS and this is my page. What are the difference? This is HTTP. So if I am doing some middle kind of attack, there is some proxy called SSL. What it does? Normally people don't use to type HTTPS or mail.google.com or HTTPS or bankingsite.com. They simply type the name of the site and browser itself you should take it to the HTTPS site. If you do it like that, make sure when you are putting a credential on the site is HTTPS not, because what that proxy normally used to do, it converts your HTTPS traffic into HTTP. How? You send the first HTTP request, the proxy used to redirect it, and when server sends a response saying that it is not HTTP, please connect on HTTPS, the proxy used to change it to the HTTP and send it to client saying it's connect on HTTP, and then you will get this thing. So from your client to my proxy it will be HTTPS traffic, and from my proxy to the server it will be a HTTPS traffic. And that's how yesterday I implemented here, and that's how I got all the passwords. People, whoever is talking on the Gmail or the no one has seen this HTTP, whether the URL is HTTP or the HTTPS, and everyone is putting their username and password without even looking at once. So that's how your HTTPS works, and they have provided the security because of this. So this is about your HTTPS protocol. Is it clear? Now you understand why you are using VeriSign or what the purpose of that? Okay, so that's all about the HTTPS protocol. What next?
This is one question.
Okay.
In case of Gmail, you were able to exploit it because it was semi-signed certificate.
I want to use the certificate kind of technique this time. If I have used that, you have got that warning. So I use the SSL strip. I just change the HTTPS to HTTP.
And you were able to take it because it was self-signed.
No. This technique is quite different. This technique is like you type the mail.google.com. You didn't type https.mail.google.com.
I'm talking about the previous case when we were discussing using VeriSign.
Okay, yeah, fine.
In that case, if it was self-signed, you were able to impersonate Gmail.
Yeah.
Right? And you were able to decrypt it because it was not signed by VeriSign or a valid third party.
If you click on OK, if you go ahead to that, if you click on OK, if you stop accepting the certificate, anyway you are not going to get the site. You will get a pop-up, that's for sure. You will get a pop-up. If you click on OK without reading that, okay, then only you will connect to the site, and then I can decrypt. But if you don't click on OK, you click on cancel, you will not get a site.
I didn't think the third party involved in the attack was just possible. I didn't think that was related to VeriSign or third party. Because there was no third party associated. That's why you were able to impersonate the Gmail site.
Yeah, correct.
And VeriSign being involved or a third party being involved. You are not involved in.
How will you involve them? That's the question. They will not sign your public key using their private key saying that this is a Google public key.
No, had Google been using third party, had Google been using VeriSign as third party.
I don't know about Google, but I know about the bank. All the banks use VeriSign. Google also use some. Of course, probably thought I don't see the certificate, but of course it is. Every HTTPS site using some CA authority, that is third party.
Usually you are able to hack the passwords of Gmail also.
Yeah, that is not that. I told you that is because of SSL